These videos are going to be about polynomial division. There's an algorithm we can use that's similar to the grade school way of dividing numbers. And we'll put the polynomial that's being divided underneath the division symbol. And then the expression that it's being divided by goes on the outside. Now, just like long division for numbers, we want to find out what it is we can multiply x minus 1 by in order to at least get rid of this x squared. And so the best choice here would be to put an x above, because if we do x times x minus 1, we'll get an x squared term, and that's what we need so that we can get rid of that x squared term. So I'm going to multiply in my head x times x minus 1. You want to remember to distribute the x to both terms here. So that's going to give us x squared minus x after we multiply it. And just like you would with the grade school way of dividing numbers, you want to subtract the results that you get here. But it is critical that we remember to put parentheses around everything that's being subtracted. That way the minus will go to both the x squared and the negative x as well. It's got to be distributed. Alright, now we'll bring down our results, do the subtraction of x squared minus x squared. That makes nothing. But here we'll have 5x plus x, it looks like. So that's going to give us 6x. And just like we would with division for numbers, we want to bring down what's remaining. So let's just drop that right down, that's 6. And we want to do the process again to see if we can get rid of the 6x. So what can we multiply x minus 1 by to get 6x? We want to multiply by a 6. That would be the best choice here. So distribute that 6 to the x and the 1. We'll get 6x minus 6. Subtract those results. And we get a 0 there, but we have a remainder of 12. So what do we do with the remainder? Well, so at the end here, we can't multiply x minus 1 by anything to cancel off a 12. So at this point, our process will actually be done. And we never divide the 12 by the x minus 1, so for that reason, when we put our final answer, we want to leave it as 12 over x minus 1. And this will be our final result. Here's another example. It's a little bit more difficult here because we see that there are some missing terms. Like we don't have an x to the 4th term, for example. We don't have an x squared term or a constant at the end. So when we set up our polynomial division, in that case, we have to leave spaces where there could have been an x to the 4th term there, but there wasn't. So you could put 0x to the 4th if you want, or just leave it blank. And we'll do the same thing for the x squared term, because it isn't there. All right, we'll put our 2x plus 1 on the outside here. Let's try to figure out what we can multiply 2x by to get 16x to the 5th. We want the largest term that we can think of without going over 16x to the 5th. So I believe that an 8 would be appropriate here, because 8 times 2 makes 16. And when it comes to the variables, we'll want x to the 4th. 2x times 8x to the 4th does make 16x to the 5th. So let's put that here. And when we do 8x to the fourth times 1, that gives us 8x to the fourth. You can see why we had to leave space for the x to the fourth term, because our result of the multiplication is an x to the fourth term. All right, make sure to put parentheses around that and subtract the results. We'll get 0 here, minus 8x to the fourth. And we can just bring everybody else down if we want. And then we'll continue with the process. So it looks like our next coefficient is going to be a -4. 2 times -4 makes -8. And then let's do x to the third so that we get x to the fourth after we multiply. So this is going to be a -8x to the fourth, and then we'll have a -4x to the third. Put parentheses around that and subtract. Now I'm going to do the distribution of these in my head here. These are going to cancel because it's a -8x to the fourth plus 8x to the fourth. And then this guy will be a positive 4x to the third, so that's actually going to take us to 12x to the third once we add it. All right, bring the rest down. And let's see, we could throw in a 6x squared here. That'll take us to 12x to the third. And plus 6x squared. And we'll get 0 minus 6x squared plus 4x. Now when we come up with our constant here, we want it to be such that after we multiply, it matches what is appearing down here. So I want to make sure that I do a -3x here, so that 2x times -3x makes -6x squared. You want them to match so that when you subtract the results, they cancel. That's the whole idea. All right, looks like we'll have 4x plus 3x, so that's going to make 7x in the end. That's our remainder. With that in mind, our final answer will be 8x to the fourth minus 4x cubed plus 6x squared minus 3x, and then plus 7x over 2x plus 1. That's our final result.